Hello everyone, I am Surendra Jain, Master Teacher in Vedantu. I am presenting you the solutions of JEE Advanced 2020. This is question number 13 from paper 2 from the topic permutation and combination. One very interesting topic and very important chapter for JEE Advanced. In this question we require use of gap method. Also you can do this question by beggar coin method. Let us see what this question is. An engineer is required to visit a factory for exactly 4 days during the first 15 days of every month, and it is mandatory that no two visits take place on consecutive days. Then the number of all possible ways in which such visits to the factory can be made by the engineer during 1 to 15 June 2021 is. Let us see how to solve this. I have actually two methods to solve this question. One is gap method. Let us see what is that gap method. So we have 15 days. Let me write them in a row. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we need to select 4 days. So let me write S on 4 those selected days. So 1, 2, 3 and 4. And those days which are not selected, let us call them as N. So this question now is equivalent to arranging 11N and 4S in a row so that no two S are consecutive. So this question can be done in now 3 steps. Number 1, that arrange 11 N's, and these will be arranged in only one way because all N are identical. Then if you arrange 11N, you have 10 gaps in between and you have one gap on the left, one gap on the right. So there are total 12 gaps on which if we put any one of the S, we will make sure that no two S are consecutive. So we need to find 4 gaps out of 11, out of 12, find 4 gaps out of 12 gaps on which we are going to put S, and that will be done in 12C4 ways. Okay, and then just place those 4 S in those 4 selected gaps, and that will again be done in only one way because all S are identical. So the total ways or number of required ways would be just 12C4, which is 495 answer. Okay, one very simple question. Let us see what could be method 2 for this one. Let us assume that engineer is making visit on nth day, mth day, pth day and qth day. So there can be some days left before n also. There has to be at least one day between n and m. This could be 1 also, this could be 2 also, 3 also. Let me call y number of days. Similarly, between m and p there will be z number of days. Between p and q there will be w number of days, and after q also there can be t number of days. Okay, so this x, y, z, w and t counts those number of days on which visit has not been made. So this x plus y plus z plus w plus t should be equal to 11. Now condition on x and t would be that they can be greater than or equal to 0, because you may make visit on very first day also, you may make visit on the last day also. In that case x and t will become 0 0, but your y, z and w, they should be at least 1, so that no two days on which visit has been made are not consecutive. Now this is similar to non-negative integral solutions of a linear equation, which we can write directly, but here y, z, w are greater than or equal to 1. So let me take y as y0 plus 1, z as z0 plus 1 and w as w0 plus 1. Why I am taking this? If we substitute this here, we will get a new equation, x plus y0 plus z0 plus w0 plus t, and that will be equal to, I think, 8. Now all variables are such their values can be greater than or equal to 0. So this is a perfect condition for non-negative integral solutions, or you can say beggar coin method. We can assume like these 5 are the beggars and 8 are the identical coins. So in how many ways we can distribute these 8 coins among 5 beggars? That direct formula, 8 plus 5 minus 1 C5 minus 1. So you can check, it also comes out to be 12 C4 only, which is 495. Okay, so that is the solution, that is the complete solution for this question. I hope you have liked this solution. Thank you so much. Stay tuned for the next question. Bye.